All right, thank you. Thanks to everyone at WLIA for pulling together this event, our virtual conference here. There are a lot of challenges everyone's been facing lately, and appreciate the effort that everyone here um, went through to pull all this together so we could still have some fun. As was mentioned, I grew up in Sheboygan, Wisconsin. So I was a little disappointed that we didn't get to head there this year. Check out some of the old, check out some of my old haunts. I grew up on the south side of Sheboygan in the 1970s. I remember fishing off the warm water outfall at the old power plant along the lake. I vividly remember seeing Star Wars in 1977 at the old Wisconsin Theater in the downtown. And every time I have gone back, I recognize there's a lot of things have changed, um, and yet some things remain remarkably the same. But other things don't look the same at all from when I grew up to how they are now. Anyway, um, we're going to be using an app uh, during this presentation called Fulcrum app. This is not a workshop or a hands-on lab or anything, but if you do want to follow along, you can get a free trial if you go to fulcrumapp.com. And if you're interested, the apps and tools that I'm going to create today, I can share those with you directly through Fulcrum. So you can see the code that's been written. You can experiment and get started with the things that we'll have already developed. So a couple of concepts that you may or may not have a level of comfort or familiarity with. The Internet of Things, that's a pretty broad topic. The things I'm going to be focusing on generally are related to environmental and situational monitoring. So I'm not really looking at the refrigerator that's going to tell me that it's time to buy milk. And edge computing is also not necessarily, it's certainly not a new concept, but with how cloud computing has evolved, it's taken on kind of a new identity. Because of a lot of the challenges that we've all been facing these last few months in particular, I wasn't able to pull together the same exact presentation that I had hoped to from the beginning. Um, there were some site visits I had hoped to do over the last couple of months for some of our mining clients where I wanted to show working with um, the sensors, particularly for mine safety, and working with those. And uh, obviously, most of our travel's been canceled, so we haven't been able to do any of that. There's also some practical concerns that I decided to overlook when we're looking at some of these demos. Battery life, when you have the GPS running all the time, for example, or when the Bluetooth is enabled. So those are definitely challenges. Um, but for what I wanted to demonstrate here, I didn't really concern myself with those. And in the end, because we're all watching this remotely, I wanted to, I guess, give it a little bit of fun. So we're gonna all go on a little bike ride together uh, during during the next half hour. So, like I said, we're going to use Fulcrum to do some of the demonstration of these concepts today. So I'm going to show you very quickly how to create a simple Fulcrum form, and then we'll pick up from there. All right, so let's go ahead and create our first Fulcrum map. We'll do just a simple one. I'm not going to show you all the functionality and capabilities here, but just enough to get you started. And we'll create another app later on that has some of the computing logic built into it with the Fulcrum data events feature. So if you are following along here, or if you've logged into your free account that you created earlier on, you should get to this page here with a green button up in the upper right hand corner says new app. So we're going to go ahead and click that. And it'll take a second here, and it's going to tell us we are in our layout mode. And really just real quickly for you, along the left-hand side here, it describes for us all the various field types that we can put into our data collection form. Basic field types like text, numbers, very simple yes, no options, dates, etc. Choice lists, which are drop-down choice lists, either single or multiple choice. Some design elements for grouping fields together, different types of media, digital signatures, photos, video, audio, and then some other fields that we'll not really get much into today. Some geocoding capabilities, calculations field, which we might touch on, but let's just go ahead and create a simple field. So every form needs at least one field. So let's go ahead and just create a text field here. We're going to call it WLIA project name. And you can see as I type the label here, it's automatically giving us a data name down below. Most of the time that's sufficient, but you can change this. This essentially is what will become your attribute ID. Several different choices here if the field should be required. In other words, they can't save the record unless a value's been entered. Is this a hidden field? This comes in handy very often when you're doing some of this computational data, because oftentimes what you'll want to do is create a field that is really just storing information that you're collecting from other sensors, or is a result of combining and calculating data based on field that the data collector himself enters in combination with some backend calculation, but it's really not necessarily to expose that resulting piece of information to the user. Is it a read-only field? You can express some validation patterns. So for example, if you need some feature name to be, say, 3 letters, a dash, and 3 numbers, you can set that. And a number of ways of establishing different rules for visibility and requirements. Again, I won't get into that right here. Let's just go ahead and create a simple yes, no field. We'll just give it again, a simple name. I don't want to take too much time with this. Let's do a drop-down option here. We'll call this inspection types. And again, this is a choice list. So right here, right in this field, we can just give it a set of options to choose from. My kids are reading Harry Potter right now, so let's go with some dragons, some snitches. I don't know if that's spelled right. Maybe a broom. And how about a Quidditch cup? I don't think I spelled that wrong. I don't think I spelled that right, in other words. So that's a drop-down field. And let's go ahead and also add a signature and a photo. And that's it. Over here on the right-hand side, we're going to give this app a name. Let's just call this WLIA demo app number 1. You can give it a description if you want, and some other things here, again, which I won't get into. But then in the lower left, we've got the save app portion. So we're going to save this. It's just going to tell us in the top right here that the app has been saved. So let's go ahead and see what this looks like on our phone. We're going to go ahead and sign in. This is the account that I created for this at iCloud. My super secret password. sign in. First time you sign in, it's going to synchronize any apps or data that you have that maybe you've updated that haven't been loaded into the service yet. So here we see our demo app that we created. Um, we can certainly go into that app uh, and tap the lower left. There are no records because we haven't created any yet. So we're going to tap the lower right, the plus icon, and that's going to go ahead and bring us our form. So here we've got those fields that we set up, WLIA project name, um, whatever we want. Inspected today. This is a simple yes, no answer that we've got set up. Here's our list of inspection types that we created. And then we can have a digital signature here, tap to sign, and then photos if we want to take any photos. I'm not going to do that right now. Go ahead and save our record. If we switch over to map view, it's going to show a red pin where we collect it. You can always move the location of that record. So let's talk a little bit about the event and the situation that caused me to want to do a presentation on monitoring and environmental monitoring. So what we're looking at here is the air quality monitoring network for the state of Minnesota, managed by the Minnesota Pollution Control Agency. As you can see, there's a dense set of monitoring stations in the Minneapolis-St. Paul area, and then a number of them scattered around the state. The orange marker on the map is the location of a company called Water Gremlin, and they, among other things, manufacture lead sinkers for fishing. And part of one of the industrial chemicals that they use as part of the finishing product is what got released into the air here. So the stations you see now are those that measure specifically volatile organic chemicals, which are the items that we're kind of talking about in this case. The previous map showed other stations that monitor other things like nitrous dioxide, particulate matter. These are the only stations, though, that monitor volatile organic chemicals. If we get in even a little closer, we can see how these sites are spread out and where they are relative to the Water Gremlin manufacturing facility in White Bear Lake. You can see that there's not a lot of opportunity there to really monitor closely to that particular facility. And so what was released or what was discovered to have been released over the last 17 years is a particular volatile organic chemical called trichloroethylene. And this is a particularly nasty VOC that's been released. So this is the area of concern. Zoomed in closer, there's the facility right along the western shore of the lake. So for a period of about 17 years, there were extremely unsafe levels of this VOC released into the air at about 12 times the level that was considered safe. And so when I read about this, I was just a bit stunned as to how something like that could go unnoticed for so long. I didn't know as much about the pollution monitoring stations that I do now, but still, it was pretty stunning to me. As a result of that incident, the company's manufacturing facilities was closed for a period of time until they were able to show that they could comply with some new monitoring and reporting requirements. And so there are a number of new both air and groundwater station monitoring directly around the facility, and they're now required to, in addition to modifying some of their manufacturing processes, they have to submit very frequent reports about the quality of the air and the groundwater around their facility. So when we're talking about IoT or the Internet of Things, um, I'd like to talk about sort of the predecessor to those types of devices, or that sort of way of deploying this technology. So broadly put, when we're talking about what I would say legacy equipment, kind of in this vein, um, is instrumentation. So that would be those devices that are installed and used to indicate, measure, and record physical quantities. Again, what we're looking at here in this particular case is air monitoring, but the instrumentation could be deployed for groundwater monitoring, um, for measuring various materials, again, in the mining industry, so that they know how much material is being processed. Uh, this equipment tends to be, again, uh, rather expensive. It tends to be very proprietary and closed. You often need just the original, you need the folks from the manufacturing of that equipment to install them. And the devices tend to also be quite passive. And so some of them can be programmed remotely, but they're not adaptive to changing conditions. So you essentially set them. It's a very particular purpose to, say, sample the air quality at a particular interval, and it's generally not going to uh, be able to change to the conditions around it. So now we move forward to sort of the evolution of instrumentation into IoT, the Internet of Things. Of course, all these devices, to some degree or another, have an internet capacity to them. What makes them really compelling is technology has evolved to the point where these things are quite small. Um, they're made from commodity parts, and so you can purchase these circuit boards, these Wi-Fi transmitters, very easily, and it's very easy to do your own prototyping if you're interested in developing devices. Uh, they're very scalable. Many of them have an open programming interface. The device that you see here being installed on the window is an air quality monitoring device, which we'll actually learn a little bit more about here in a moment. But that has a web accessible programming interface or, that you can use to um, modify the settings of the device, and then also retrieve the data from these devices. And these types of devices also tend to be cloud native. Now, cloud native is a particular term. It does have an actual specific meaning, but broadly speaking, what that means is these devices function and expect to be operating in a cloud environment. There's also another class of personal devices. Maybe it might go by the term of say wearables. But these, like in this particular case, what you see is a small air quality sensor device manufactured by a company called Plume Labs. Um, this is all green, so it's telling me that the air quality here in my office is good. But this is, a personal device. I'm gonna hang this on my work bag as I walk through the airports. I'm gonna have this on my bike when we go on our bike ride a little bit later. So it's a very personal oriented device. You can see here, looking at the relative air quality index on my daily commute. I live in the bottom part of that map that you see and work up in the northern end of that route. So you can see my commute route. And again, as we know, green is good, red is bad. And so higher polluted areas closer to where I work. So we're going to learn a little bit more about the AQ mesh devices that you saw in the previous photo. And then we're going to take our flow device here, and we're going to go on a little bike ride. And as we do that, we're going to learn a little bit about how we deploy Fulcrum in the context of the human sensor and interacting with these IoT devices. Hi, here we are at Highland Park Middle School in St. Paul, Minnesota. And on the light pole here above me, there's a device installed. That is part of the Minnesota Pollution Control Agency's Urban Air Quality Monitoring Network. There are about 42 devices installed throughout the Twin Cities area. They've guaranteed, in fact, that there's at least one device installed in every zip code within the core metropolitan area, Minnesota and St. Paul. And these devices are a new project using these more modern devices. These sets of devices happen to be manufactured by a company called AQ Mesh. You can learn more about that at the links that I'll provide at the end of the presentation. But these devices really are more of this modern network, more modern technology approach that really fits into the Internet of Things spirit of how this type of technology and data collection has advanced. With me also, I have something that I've already mentioned to you. This is my personal air quality monitoring device, the Flow 2 by Plume Labs. So you can see if we push the button, hopefully the lights show up as green. Yep, they're all green. As map makers, you know, of course, green is good and red is bad. That's always the case. And so what I'd like to do is take you on a little bike ride. We're going to start with this device here above me. I'm going to hang this personal device on my bike. We'll start up a little Fulcrum app that's going to collect information from this personal device as we take a 15-minute bike ride up to McAllister College, also here in St. Paul, which is another location where one of these AQ Mesh devices are installed. This device network does provide the data available in real time from AQ Mesh. The Pollution Control Agency doesn't provide real-time access to these yet, and so there's about a 3-day delay on the information being made available to the public from these devices. So we're going to go ahead and collect our data today. We'll check out the Pollution Control Agency's data site in about 3 days, and we will see what we've got. So let's go ahead and build our new Fulcrum form here that we're going to use to actually collect information from our air quality sensor. I've got a form started here already that we would be using. It's got some basic information, maybe a feature name or a route name, a date, a couple of links here for collecting decibel levels and air quality. That's essentially going to be like treating them like buttons. We'll show how those work in just a moment. And then where the summary data is going to live that we collect, some notes, videos, and audio. But really what we're interested in here is the data events page. So data events are actions that you can set up within Fulcrum. They might be things like popping up an alert to a user to let them know that something needs to be done. It might be an action, as in the case that we're going to use here, to contact a web service to pull down some information. Or it might be an action to communicate with another app on the phone or on your tablet to pull information from another app. We're also doing that here as part of our demo. And then you associate actions with various events. So an event might be when a new record is created, carry on one of these actions, or when a particular field is made active, or when a record is saved. There's a variety of different events that can be selected. If we got them up here, for example, whenever a new record's loaded, whenever a record's unloaded, whenever a record is saved, etc. So all the data events are expressed in JavaScript. So if you know JavaScript, then you're good to go. I'm just going to paste in a little bit of code here to get us going. So here we've got a function we've defined called get SensorLog. Whoops, sorry, I put the wrong one in here. We're going to do one called get weather. So this is a function that's going to be used to get the current weather conditions when we click a button. So we've got just setting a variable here with the URL for the Open Weather Map service, where we're going to get the current weather based on our current location. And then we set up this request handler that is going to send a request out to that URL, to that Open Weather Map service. If there's an error, it's going to pop up an alert for us. Otherwise, it's going to deconstruct that data that it gets back. And then it's going to set the value of another field in the form. In this case, it's the current weather field. So when we get going out there, we'll see how that looks. And so it's going to populate the current weather when we click that. So that's the action. What we need to now is associate that with an event. So we'll grab that right here. And so get current weather conditions, right? And so here we're saying the event on click, get current weather. So when we click the current weather button, then it is going to go ahead and run our get weather function. So we'll go ahead and save that, save our app. There are options here to preview the app, and we'll just go ahead and bring that up on our phone, and then you'll be able to see what that looks like. So here we've got our app is up, and we're going to go ahead and create a new record. I'm just going to click the get weather, click the weather button, and there we go. It's going to populate the current weather for us. So we've got our app. We can communicate to our sensors. Let's go for a ride. We're going to go ahead and hit the add new record button down in the lower right, plus button. So that comes up with the form we made earlier in our little exercise. So we're going to just put in the feature name. Let's call it the WLIA road trip. We'll do it all caps so people know that it's very important. And we got the date there. It's defaulting to today, but we'll just pick a different date. And then we've got two options there for collecting decibel levels and collecting air quality. We're going to just hit those manually to get things started. We could have those run automatically when the record is first added, so that you didn't have to manually interact with the app, but we're going to go ahead and we left the buttons here so it was clear that you could tap it. And then we'll take a look at some of the results after we collect the record. We'll take a look at the chart, I think, for the decibels. So here we go. Let's collect, so collecting decibel levels. And we're going to tap then the air quality, collect that. Oh, it says air quality is already running, so I must have already started that. So we're ready to go. It's collecting that data now. Let's just take a look at our decibel levels here through the SensorLog app. And here we go to there we go, decibel levels. So the red line is showing our peak decibels. Blue line is showing the average levels. So it's pretty jumpy because I'm talking. And so let's go ahead and set that. Yeah, let's set that down to like 5 seconds so it smooths it out a little bit here. All right, there we go. So we're all set. We're recording our decibels. We're collecting our air quality. Let's go. while we're enjoying our bike ride, I thought we could talk a little bit about edge computing. So fundamentally and most simply, edge computing is this design where computation and storage live near to the source of information as opposed to central to the information. So pushing out computing and storage resources closer to the devices. The edge concept in and of itself isn't really that new, but what is new is the 2.5 billion people with smart devices in their hands that are mobile and the exponential growth in smart enabled IoT devices. So from about 2005 to this year, 2020, we really focused on the mobile cloud's centralization. And so the focus was all on the information from our devices finding its way through the communications network into the cloud where data was stored or information was processed and then sent back out. In an edge intelligence distributed environment, we start pushing things back in the other direction. And so we find that the resources contained in the cloud, the compute and storage and resources, are pushed back out closer to the devices. So why would we do this? Why would we want to or need to push the edge, push these resources closer to the devices? Well, there's a lot of practical reasons. 5G network connections are going to speed things up for us as far as access to centralized compute resources. But as is always the case, we will find a way to consume those resources. Security is a is also uh, an aspect. You know, the most secure data is that which never leaves the device, and just the sense of being able to have a more resilient network with these resources pushed closer to the edge. Fundamentally, though, all those things really stem from this bottom metric here, where we have billions of devices out at the edge, and the security aspects, the bandwidth aspects, and a number of other reasons are reasons that push us outward towards the edge. So building on this, you know, there are the sentiment essentially is that all the computing resources or everything that can be centralized already has. And so the real opportunities now lie back out at the edge. This is realized most recently, I think, late last year, with a new partnership formed between Verizon and Amazon Web Services, where Amazon will actually begin to deploy web services systems, compute resources located at the edge of the Verizon wireless network. And this is going to include all the way down to the cell phone tower level. So if you keep in mind that at these cell phone towers, we obviously have network access and we have power, and very typically we also have backup battery power. And oftentimes we also have facilities in which could be expanded to then simply include additional compute resources. And so, whereas in the past, this communication network really served just to transit data back and forth between our devices and the resources that needed to consume that data located in the cloud. These communication nodes themselves now really become full enabled computational resources. Here we are at beautiful campus of Macalester College, also here in St. Paul. At the other end of our little bike ride on data collection and edge computing. And just a moment we'll take a walk over to the other AQ Mesh air quality station. All green. It's good to see. So here we are at our destination of our little air quality journey here at the Macalester College campus. We've got another monitoring station located on the pole here. Interestingly, a lot of them seem to be installed on light poles in parking lots. I'd be curious, as a side experiment, what maybe the fumes on a day like this coming off the asphalt have any effect on what's being collected here. But nevertheless, I hope you've enjoyed our little journey and our discussions about edge computing and the evolution of and tying that to the Internet of Things, some of our little data collection experiments. So I hope you've enjoyed the day, and thank you. We'll see you at the happy hour. So I just wanted to kind of wrap things up here and talk a little bit about how, now that we've kind of gone through IoT and the human sort of interface with combining and collecting sensor data, and then we've added the edge computing component to it. I'd just like to wrap things up a bit here and talk a little bit about machine learning. So just in case, to give a quick review, where machine learning kind of falls into the stack of analytics. Uh, Here at the most basic, we can perform descriptive analytics, which essentially just tells you what happened in the past. So to some particular event, you've got a data series. You can apply some basic descriptive statistics, descriptive analytics to it, and it will kind of lay out for you what happened, and from it you may be able to also discern why. From there, we can bump up to predictive analytics. So there we're looking at, I guess the most simplest form might be a regression analysis, where we've developed a very simple mathematical model that to some degree of error or certainty will provide a prediction for us under similar conditions, what might happen again. And then finally, prescriptive analytics, which is where machine learning really comes into play, is not only predicting what happens, but what we should do about it, and maybe ultimately even taking that action itself. So it's prescribing what the right course of action would be given a machine learning model. So as far as what we've been talking about here today, there's a couple of different angles that could be applied here, specifically with Fulcrum, again, leveraging the Fulcrum technology or leveraging uh, computing capabilities at the edge or in the traditional cloud. Two ways of looking at this: Fulcrum Machine Learning Mobile and Fulcrum Machine Learning Edge. So Fulcrum Machine Learning Mobile, this is where we're running machine learning models on the device itself. Um, and it's maybe taking into consideration data records that you've entered with your own observations, plus data you collected with a sensor. Um, Given the, albeit relatively speaking, pretty powerful computing devices, probably would be looking at running simple models, relatively simple machine learning models on the device itself. So we're looking at two different ways of doing that. TensorFlow JS, which is a JavaScript expression of the TensorFlow environment. So that potentially could just be developed using a Fulcrum data event. Again, since that is essentially just a JavaScript interpreter. Or TensorFlow Lite, which is more of a full development environment for creating models. And so using both of these tools and these environments on the device, we could see how we could either say take data that we're collecting on the device and use that as a training data set in order to condition a model that a machine learning model that we'd like to build, or if we've got a model on the device that we'd like to deploy. For example, what comes to mind might be imagery analysis. And so if I'm taking photos with Fulcrum and I want to perform some sort of information extraction from those photographs, and then take that and write that out to other fields in our form, that might be one approach or one implementation. The other model is machine learning, kind of more in the traditional sense. So this, though, is cloud-based machine learning or at the edge, where we're really taking a combination of data collected by a variety of Fulcrum users. It could be your entire fleet of workers, for example, that are using and collecting data with Fulcrum. All of that collectively goes in, again, either to feed, to train and develop a model, or as inputs for decisions that an existing model is going to make. These could be pretty complex models because, again, we're running those in a high performance computing environment, either at the edge or kind of at the cloud core. And for this, we've just started looking at Amazon SageMaker, which is really just sort of an implementation of TensorFlow environment within and kind of built around the Amazon Web Services environment. So thank you for your time, and hopefully you got some interest out of this. I know I got a nice little bit of exercise on that bike ride, and there's some references for you shown here. You all have the power of Google these days, right? So we don't need to paste web addresses in anymore. You search for any of those terms, you'll find it. Again, if you do sign up for a Fulcrum trial account, um, contact me at my email address there, and I can share the Fulcrum forms that we created here today with you for you can get started. Thanks.